Namaste, welcome to this channel Chemistry Made Easy by Dr. Muri. Today we will discuss the periodic table, the second point of this topic, atomic structure. So here the development of periodic table begins with initial attempts where the scientist Dr.ARM proposed his concept, that is his triads, Dr.ARM's triads, in which he showed that when the atoms in the series, that is A, B and C, with increasing order of their molecular weights were arranged, then it shows that this atomic weight of B is equal to atomic weight of A plus atomic weight of C divided by T. So this is the average, that is atomic weight of this plus this divided by 2 gives the atomic weight of B. This is one Dr.ARM's proposal of his triads. Then Newland's octaves. Newland also developed his method of arrangement of elements. He arranged also the elements in increasing order of their atomic weights, and he found that the properties of, say, any given element are repeated in the next 8th element. So that is period. So after 8th element, so he said it is the octaves. But this method, these two methods were initial developments, and these cannot explain the every element in this method. So later on, Mendeleev and Mayer Mayer. These are the two different scientists. They proposed also the method of arrangement of these elements in increasing order of their atomic weights. And they said that the atomic weights, that is, are the methods, these are the functions of their periodic properties of the elements are found to be, in that case, are found to be the functions of atomic weights. So this method of the arrangement or organization of different elements were found to be more superior to previous attempts. And in this method, these two scientists said that the elements were arranged in horizontal manner, horizontal arrangement shows that this is called a period. The horizontal arrangement of elements gives a period, and vertical arrangement in columns is known as, or they proposed that these are called groups or families. Further, they also divided these elements into various blocks, that is blocks. So these are S, P, D and F. So these blocks are considered on the basis that These are the valence shells of respective elements. When it is called a S block element, it shows that the valence electron is there in the S subshell of that element. Similarly, the elements shown in P block are having their valence electrons in their P subshell. Similarly, in case of D, the valence electrons are present in the D subshell. In this case also, the valence electrons are also present in their F subshell. So in this way, developed various blocks are also considered. Now we will see the actual periodic table, and we can see that this is the structure of a periodic table. Now we will see that the periodic table is arranged in specific manner so that it will be easy for one to understand the properties of that particular element, or it will be suitable to understand the periodic trend of properties. So we will describe this periodic table in this way. First of all, we will arrange these elements, say in this way, in two rows. So this is when n is equal to 1, that is first period, we can have this element, this type of arrangement. So here, so it requires only one box. Then there is n is equal to 2. So we can use this period. For n is equal to 3, we can use this period. Now that will be extended further. Then n is equal to 4, we can have the box like structure like this. Then n is equal to 5, it will have structure like this. Then n is equal to 6, it will have also box like structure like this. And n is equal to 7. So this will give us the S block, that is S block of elements. Later on, these blocks are also further extended here in this way. So these are extended in this way. Now we will divide this block. So this is the part of D block. I will divide this into 10 groups. So this will be the first, second, third, fourth, fifth, sixth, 7th, 8th, 9th and 10th. So these are 10 groups. Now we will have this extension here further like this. It will have 6 groups. So we will show that these are having 6 groups. show these 6 groups in this way. So here we will have the first group here. Now we will divide this into 6 groups. This is 1, 2, 3, 4, 5, and 6. Now we will extend this further here in order to add the remaining elements. N is equal to 2 and n is equal to 3 in this way. Now we will show this extension here. Now we will give the names, or that is the groups. Groups here. So this is first A, then it is second A, then there is third B, then this is fourth B, fifth B, sixth B, 7 B, and this is 8 B. So this can cover these three groups, that is 8th B, then next is 1B, and this is second B. Then here it is next group, that is third A, fourth A, then it is fifth A, sixth A, 7 A, and this is 8th A, or 0. Now we will show that this is S block. Then from this to this, it is D block. Then from this to this, it is P block. one more block. So that we can show here at the bottom. So it will have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14 boxes like this. Now we can have the structure of this periodic table like this. We can also give the names of groups in this direction as group number 1, group number 2, group number 3, this is 4, this is 5, 6, 7, this is 8, 9, 10, 11, 12. Then there will be this 13, 14, 15, 16, 17 and this is 18th group. So in this way there are 18 groups in this periodic table and there are how many? 7 horizontal rows, horizontal rows called periods. So these are the periods we can show here. So we have shown here the periods like this. Now we will show the number of atoms or the atomic numbers of elements present here. So first is hydrogen with atomic number 1. Then here it is helium with atomic number 2. Then we come here in the again first. So that is with 3, 4. Then we come here with 5, 6, 7, 8, 9 and 10. That is neon 10. Then here again 11, 12. Here it is 13, 14, 15, 16, 17, 18. Then, so we will, there is one more extra group, so that we will merge here because there is extension. So we will show this in this. So with this second period here, this is second period. Then there is n is equal to 3, that is third period. So it will have only 2 rows, 11, 12, 13. So we will have here 13 and again come back. So we will enlarge this structure in short. Enlarge these groups or boxes so that it will be of equal size. So we can have this one box and second, that is third, then we'll have fourth, fifth, then this is fifth, sixth, 7th, 8th, 9th, 10th element. Then 11, 12. Then here it is 13, 14, 15, 16, 17, 18. Then here it comes 19, 20, 21. We use another color. 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. This is last element of this D block. 31, 32, 33, 34, 35, 36. So in this way we have 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 46. 46, 47, 48, 49, 50, 51, 52, 53, 54. So in this way we have here 55, 56, 57. Then we have to go here, next element, that is 58th, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71. Then we'll continue here, that is 72. 72, then 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86. Then here it will be 87, 88, 89. Then we will have another stage. So we will have this another symbol. We will use another symbol, that is hash structure. This is asterisk and this is hash structure. So next elements of it should be here. Like this. So after 89, here it is 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102 and 103. And afterwards the next element will come here, that is 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118. So in this way it gives us the periodic table. So these are the atomic numbers. So first these elements. So this first group, that is, it contains 1A is called, that is S block. So it contains two types of elements. That is 1A. 1A group is alkali metals. alkali metals. Then second A is called alkaline earth metals. Alkaline earth metals. Then these G block elements are also called transition metals. That is called transition metals. And these two elements are called inner transition metals. So these are various groups. So these are further called 4F elements, 4F, and these are called 5F elements, and this is called F block. So these inner transition elements are called F block of elements. Now we know that these elements which are present here in this 18th group are called inert gases, inert or noble gases. Then these are called halogens. Then these are called, next to this, these are called chalcogens. And 15th group elements are called pnictogens. So these are some common names used here. So this is about the structure of the periodic table. So these are the numbers are representing atomic numbers. So we get, for example, alkali metals 1A group, that is hydrogen, lithium, sodium, potassium, rubidium, cesium, francium, etc. Similarly, we can get here also B, Mg, Ca, Sr, Ba, etc. So here we get the first transition series. So there you will find in this D block, these are 4 D series of elements, out of which this line indicates up to here it is first D series. It is called the 3D series. Then this is 4D, 5D and 6D. So in this star and hash indicates addition of in between 57 and 72. These are 14 elements, and in between 89 to 104 there are another 14 elements which are shown separately in the form of F block. So these are called inner transition elements because these are considered as a part of this transition metals or transition elements which are present in the D block. So this is about the periodic table. So later on we will discuss whenever it is required what are the periodic tracing properties. So till then, goodbye, see you next time. Please keep watching this video, share this video, and please press the bell icon button and like button. Thank you very much.